Hello, good afternoon, everyone.
Afternoon there.
This is session 1D. I welcome you all to this 7th International Congress on Information and Communication Technology through Zoom. Further, as we all are aware, we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable times and making this conference more productive. We hope you will enjoy 2 days of the knowledgeable and interactive digital sessions. Also, there is a special note for the presenters. You will be given 10 to 12 minutes for the presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. So please be aware of that as we have technical sessions parallelly going on. So to avoid the further delay, please take care of this. I also request all the other participants to be on mute while the presentation is going on. Just to get started, I would like to introduce our session chair today, that is Alina Miron. I welcome you, ma'am. Alina Miron is an associate lecturer at Brunel University. She has obtained a PhD in computer vision from France. She worked for several years in industry as a programmer and data scientist. Her main areas of interest are machine learning, artificial intelligence, and computer vision. Thank you for your presence, ma'am. So we have our first presenter, Vivek, with us, Vivek Sharma.
Yeah, hi.
So just a minute. So you will be presenting a paper on a survey on research directions in blockchain applications usability, right? Thank you.
Yeah,
so you
that's
can
correct.
begin with your presentation.
Okay. Can you see my screen?
Yes, I can see your screen and you're audible as well. So you can start. Thank you.
Thank you. Thank you, Deepika, I'm sorry. So my today's topic is survey on research directions. So hi, I'm Vivek Sharma, and together with Zipura Halevi, we are affiliated to City University of New York. And we have, so this is a literature survey on research direction on usability of blockchain-based applications. So the motivation for this research is there is a growing trend in user blockchain-based users, but it's still, the number is still at 81 million if you look at the blockchain wallet users. And the adoption rate of blockchain-based application is limited. So according to the survey, I mean, close to 90% of the project has failed, and there is a, so usability can help improve the adoption rate of such applications. So this was our motivation to analyze research direction in usability studies. So blockchain is the future. Lots and lots of companies are investing millions of dollars in blockchain-based projects. So here are some statistics, like it's expected that company will spend 20 billion on blockchain. There are 24% of companies expect to invest between $5 to $10 million. So there are companies who are investing on blockchain, but yet the adoption rate remains poor. So the aim of our research was to find the current research direction in usability research of blockchain-based application, find out the prime challenges why the adoption rates is low, and find the proposed, analyze the proposed solutions that these papers have found out, and hence conclude the future research direction. So the methodology was, we defined the inclusion criteria, which was, we found all the papers which included blockchain usability and blockchain applications in their metadata, in their full text. And these papers were published in last 5 years, from 2017 to 2021. And the exclusion criteria was paper which were not published in English, paper which were literature survey or systematic reviews, and papers which didn't discuss about usability of blockchain application. So we excluded those papers. The search database were the top well-renowned databases that we searched papers from, and we found 22 relevant papers on this topic. So this is the first result, that most of the usability studies were in finance domain, followed by health, and then we have other domains that we found usability studies in. So finance, it was very unsurprising that finance remained the top choice for usability studies, because lot of end consumers are using finance. I mean, it's interchangeable, the blockchain and Bitcoin. So the thing is, most of the studies were in finance. And if we look at the methods that were used in usability studies, we saw that user survey method was the most used method, followed by expert surveys and observational studies, and so on. So if we look at the total number of participation in user-based studies, so in novice user-based studies, the users have limited knowledge in blockchain, whereas in expert studies, the participants were the users who have worked in industries. So if we take novice user-based studies, the number of participants were less than 40, whereas in expert-based studies, the number of participants were less than 20 among these studies with these methods. So if we look at the health domain, so the articles mostly talked about implementing blockchain, the privacy issue, data usability issues in managing data in electronic medical record. And if you look in finance, we found some problems. Users were hesitant due to lack of regulatory body. There were involvement of local government might improve the adoption rate. And these articles found that credit and debit cards were much more usable and secure than Bitcoins. So what we segregated the goal of studies in different domains. So if we see these three boxes, in cryptocurrency, it was mostly user perception on cryptocurrency. In health, it was challenging in data management and user perception, because there was this privacy issue, that the data might get leaked or sensitive info might get leaked. And if we look at the multi-context blockchain, it's a general blockchain which is applicable in any domain. So again, these studies that we studied were looking at identifying and assessing the risk. They saw that user perception on adoption of blockchain. Some have developed the application and tested their applications to find the usability of their application. Then we saw the primary challenges. These were the top primary challenges among these papers. The challenges were risk of sensitive information being exposed, difficulty in using and managing the applications. User found out that lack of regulation hindered their adoption of blockchain. And whereas in supply chain management, they said that lack of non-standardization, integration, and standard platform were the prime reason that they didn't adopt blockchain. So even they proposed a solution that improved transparency can help improve the adoption rate of blockchain-based application, creating simple and usable application, some regulatory support, adding warning, or maybe educating the users and defining quality of service were some of the proposed solutions by these articles. There was some other insight that one of them were only 9 out of 17 studies, user survey studies, they reported gender related data. So rest of the paper, the article, they didn't showed this gender related data. Whereas, I mean, so this gender related data are basically the number of males and females in the number of participants. So they reported number of participants, but they didn't report how many of them were male, how many of them were female. So future work is to look further into these demographic roles and how a bias is introduced with these unreported data. So for conclusion, we saw that high number of blockchain usability studies were in finance domain, and there is limited number of usability studies because we could only find 22 studies on usability of blockchain based applications. And in EM, so in health related domain, data management and privacy concern were the top um, issues, whereas in finance, it was lack of regulation, lack of knowledge, risk of sensitive information being same in both health and as well as finance. And in supply chain, the participant felt that integration and use of shared platform will improve the adoption rate. So with this study, um, we aim to summarize the challenges, summarize the solution, so that researchers can um, get a head start in this field. So, and that was our aim. That's it. Thank you.
Thank you very much, Vivek. Any questions? I see. I'm sorry, I don't know how to pronounce your name.
I'm
It's
sorry, it's
Vivek.
difficult to pronounce it. You can call me
Oh,
Ryan. Okay, this is Ryan from Nara Institute of Science and Technology, Japan here. Thank you very much for your very interesting presentation about the blockchain, because I'm also interested in the blockchain. Speaking of the challenges of the blockchain, I really think I didn't see any challenging from your talk. I think the energy problem and hardware resources and how to offer the computations and storage and something like this, because my group is doing something like this. So it's totally different from Bitcoin stories. So medical science and the medical applications, nobody can offer the money to these blockchain problems. So who can offer the computational hardware resources? You can never use a supercomputer, right? Isn't it?
yeah. So we saw some studies, and it's in our paper. So what we did was we just summarized some of the prime challenges. But yeah, as you said, that's correct. So there were challenges in adding these data, because there's a problem of data storage, because in electronic health media, I mean in electronic health record, you cannot upload. I mean it's very difficult to upload like MRI scans and other things. I mean, it's easier to upload some past prescription or something, but it was a challenge. And there were some two papers. So it's in our paper, and we have reported that they have found some workaround for these problems. So yeah, such problem do exist, and it was not in my presentation, but yeah, we have highlighted them in our study, in our paper.
Okay, thank you very much. I hope you
Thank
can
you.
find more papers on this field. Okay.
Sure. Thank you.
Thank you, Vivek. Thank you for the presentation. We'll
Thank you,
move
Deep.
further. So our next presentation is by Zhang.
Okay, that's me. Thanks for introduction.
You
And
would be presenting on efficient support vector machine towards medical data processing, right?
okay, yes, it is correct.
Thank you. You can start.
Okay, thank you. Thanks a lot for your kind introduction. And I think I would like to replay the recorded video, because it's so deep night here in Japan. I don't want to be disturbed by my kid. So I'm sorry for that.
All right,
Can
sure.
you see my screen?
Yes, I can. I can.
Okay, let's get it started. Perfect.
We cannot hear very well, so we
Yes.
can see the presentation, but we are not
Okay.
able to hear.
Oh, okay, I'm sorry. So then I would do this by myself. I'm sorry. Let's do it. And let's do it. Sorry for the time. So this presentation is about our project about the SVM support vector machine applications for medical data processing. The outline of my talk today. So firstly, I will very briefly introduce the mechanism and very simple and naive use, how to use SVM in medical science. Just like this, I don't think it's different to any other machine learning applications, like the image processing, video processing, something. We just, like here, we just extract the features, I mean, the indexes of physical indexes like the heartbeat and sleep quality and diet and blood pressure and something like this, even the clinic images into high dimensional vectors like here, and we use some machine learning classification algorithms. In this work, we use SVM, and in other projects, we use different classifiers to do the classification to judge if people is healthy or sick or something like this. It's quite easy to understand, right? But reality is no any clinic doctor will trust the machine learning's result, isn't it? So support vector machine might be the perfect option for this task. I will talk about the reason why later. So this page is about the mathematical mechanism of SVM. How can we do the classification by SVM? But it's out of scope of my talk today. So the basic idea and basic task is to make decision boundary to separate two classes of data, red points into blue points. And the keyword is that support vectors, we want to identify some important samples, not every sample, but greatly reduce the total number of samples. So we call those samples located quite close to the decision boundary. We call it support vectors. We think those are very and quite important samples in the classification tasks. So that means we can greatly reduce the total number of vectors in samples. Then the meaning is that if we can reduce this number, then clinic doctor can only refer to those important cases. We call it medical cases. Then by reviewing them, medical doctor makes a decision like this mechanism. And this such kind of diagnosis assistant system is not diagnosis system, right? So we need the AI, artificial intelligence, and at the same time, we also need the clinic doctor. Not only AI makes the final decision. So clinic doctor just refer to some information, some key critical data from the artificial intelligence. For example, in case of SVM, so the AI offers some important samples and cases. We call it support vectors, including some parameters to the doctor, and on the basis of those things, human doctor makes a final decision. So obviously, there is a trade-off between the number of support vectors and the accuracy, I mean, the performance of the classification, how to break this trade-off. That's my topic today. Let's see the very simple and naive example. So we use this Wisconsin Medical Center database. This is breast cancer, including about 700 people, and the sample is 10-dimensional vector. If we use SVM, very simply use it, just use it like a live SVM or something, then we will find a large number of support vectors is necessary. For example, I'm sorry, it's not so clear in this figure, but 676, something like this. Then the classification result will be 100%. It's perfect, right? But if we change some parameters of SVM, then we can reduce the number of support vectors to only 50. Then the result accuracy greatly reduced to like 60. It's not good. So there are two problems of this original and naive SVM. One is that originally SVM is developed for two-class classification, but in medical field, it doesn't work, right? There are many classes, much larger than two. And another problem is about trade-offs, number of support vectors and the accuracy, how to maintain the performance of and the quality of service. At the same time, reduce the number of support vectors, because this number is quite important to human doctor. Okay, we put two efforts. One is so-called we develop some new ideas, so-called one-class classification for SVM, and another idea is constantly online learning strategy for SVM. Let's do this one by one. So we call it data domain description method by using support vector mechanism. For example, we have some database like these red points, and obviously if we can use very big circle like here, we can include almost all the exactly all the red points, but it's not good. It's too big. Then it will include many other wrong points, right? Blue points or something else. Then we shrink the size it and shrink and finally touch the boundary and change the shape. It becomes perfect. If we can achieve this mechanism, then we can theoretically extend the total number of classes into infinite. It's basic understanding. So this is another multi-class classification for SVM. It's very widely used here. We need upside classes to do this. By using libSVM, is quite popular and famous one. If you just look at the result, you can find in our method, we can greatly reduce the number of support vectors. At the same time, the accuracy is better than those by libSVM. So this is mathematical works, but I don't have time to introduce this. If you got interested, please kindly read our paper. So another effort is constantly online learning strategy. So if you are doing some online learning strategies, the common way is something called incremental online learning strategy. But in our case, we just use constantly. So a look at these two examples. The left side, you can see if we use many huge size of database, of course, your boundary could be quite good and perfect, but the cost and computation time is quite long. In this case, if we use so small size of database, then the boundary is poor. Performance is also poor. It's just trade-off how to break it. In this case, this is the ideal case. If we use a smaller number of vectors, but most of samples are quite close to the boundary, that's perfect, but it's ideal. So how can we approach that? At the beginning, we just randomly select some small size of database and do the machine learning initial SVM learning. And when the new case comes, we can make the inference to do the classification, what is blue or red, in this case, blue. Then we evaluated every support vectors here and replace the weakest one by this newcomer and do this and learning again, training again, and do this classification again online. Then we can reduce the total number and achieve something like this. So we verified 3 databases: breast cancer and diabetes and liver disorder and something. So this is the results. Just compare some advanced technologies by SVM. This is the ensemble SVM and CSA SVM. This is our method. Of course, when we can use larger number of samples, like here we use more than 600 in their work, they just use 200. Then 100% is perfect. But if we just reduce the total number of support vectors to like 90, we can maintain some performances by using the online learning strategy. So in this case, our performance is also better than this in this one, the liver disorders. So as a conclusion, we can see SVM helps diagnosis, but please do never think about those machine can substitute the human doctor and replace the human doctor. It's never happened. Anyway, and we developed some one-class classification. SVM is very flexible and practical in medical field. And we propose the constantly online learning strategies, which is very, it's just perfect for the SVM implementation in medical science. We verified 3 real-world database: breast cancer, liver disorder, and diabetes. Looks quite good result. Thank you very much for your kind listening. Thanks.
Thank you so much, Renyon, for your presentation. Are there any questions? So I have a question for you.
Okay, please.
I've seen recently, well, in the past few years, I've seen quite a lot, quite fewer articles that use support vector machine. And most of the articles seem to shift towards deep learning.
Exactly.
What do you think are the advantages of support vector machines in this situation?
Okay, thank you. It's very smart and very sharp question, actually. So I think the answer is on this page. If you are doing some image processing and video processing, never use SVM. It's out of time. It's old school. Just use convolutional neural networks. But please remember, clinical and medical science, we are not using the machine to make the decision. We use a human doctor to make the decision. So because my wife is a doctor, she's doing some diagnosis not on the basis of result of machine learning, but machine learning just offers some very important information to the doctor. Like SVM, we can offer some support vectors. That means very, very important cases, just like 20 or 30. For example, my wife, she has no any time to review 101,000 cases in his career, just 20 or 30, very not typical, but very weird, but very helpful, strong cases will help her to do such kind of things. So SVM is a perfect option to the medical clinical diagnosis systems, but never use it in the image processing. It's out of time. That's my answer to this kind of questions. Thank you, but it's really nice one, I think.
Thank you very much for the explanation. And I totally agree with you that there is a place for deep learning and CNNs. And I think still like the traditional machine learning algorithms still have a place because they're quite fast and a lot of them are explainable.
Yes, exactly. Thank you.
Okay. Any other questions? Okay, then I guess we'll go to the next speaker.
Yes.
Thank you very much. I will stop it. Thank you.
So our next presenter.
Me? Okay.
Nico.
Kunihiko Takamatsu.
Who would be present. So you can start.
Okay. Wait a minute. これか。
Yes,
Hello everyone. My name is Kunihiko Takamatsu. Today, I will talk about a new concept of digital transformation and institutional research and information and communication technology in higher education based on eduinformatics. Today, I have three topics. The first topic is introduction and research question. The second topic is about practical examples. And the third topic is conclusion. Now I start introduction and research question. This slide shows a recent key term in higher education. Evidence-based education, EBE, institutional research, IR, learning analytics, LA, information and communication technology, ICT, digital transformation, DX. This slide shows the Society 5.0. Society 5.0 first spread into the business field through Japan Business Federation. The concept of Society 5.0 has an easy link to the concept of Sustainable Development Goals, SDGs. I think many people know the field of bioinformatics. Bioinformatics is the word or field combination between biology and informatics. To quicken this research, we propose the concept of eduinformatics, a novel field of education that combines both education and informatics. In 2018, the term is a portmanteau of education and informatics. This figure shows the concept of eduinformatics. The field of education provides problems to be solved to eduinformatics. Eduinformatics deals with students' data and provides novel analytical methods and concepts for using data in education, similar to bioinformatics. This figure shows the effectiveness of eduinformatics. Eduinformatics is a necessary concept in this age of the rapid development of ICT. Today, a large number of educational data points can be easily accumulated using LMS. Establishing eduinformatics can further accelerate evidence-based education or institutional research and learning analytics, which in turn will improve the quality of higher education. In this study, we set the research question as, in higher education, how do we link digital transformation and education to refine the quality? The next is second topics. The International Conference of Data Science and Institutional Research 2017. We presented a new way of visualizing curricula using competencies, cosine similarity, MDS, and scatter plotting. This is a good practical example to get the answer of our research question. So I will introduce about it to you shortly. These figures show the Tokiwa competencies, 9 Tokiwa competencies. Shows the relationship between 14 courses and 9 Tokiwa competencies. In Kobe Tokiwa University, faculty have to show the relationship between courses and Tokiwa competencies in their syllabus. This figure shows the final result of this research. Visualizing curricula using Shirabi using 9 competencies for 40 courses. Next, I introduce the example 2. In 2020, we presented new visualization of competency-based education, CBE, in higher education, institutional research. In this research, we used Tokiwa core competencies instead of 19 Tokiwa competencies. Tokiwa core competencies consist of knowledge, thinking, imagination, and citizenship. As you can see in this figure, the first year student mostly gain the core competency of knowledge. In the second and third years, students gained not only the competency of knowledge, but also those of thinking, imagination, and citizenship. The ratio of thinking, imagination, and citizenship in both the second and the third year is higher than knowledge in both the second and third years. Actually, instructors in the Department of Oral Health use the bar chart as a basis to advise the student. The chart was calculated by combining raw data, the number of units, and the ratio of Tokiwa core competencies. So we can understand this data as high-resolution GPA by competencies. This type of GPA data using the radar chart for some abilities was reported for a diploma supplement. The final topic is conclusion. Again, I show the research question to you. In higher education, how do we link digital transformation and education to refine the quality? First, we developed Tokiwa competencies to evaluate or link 5 policies: admission policy, curriculum policy, diploma policy, assessment policy, and our original student support policy. We then could not predict how to use these Tokiwa competencies in university reform because the syllabi of all the courses in Kobe Tokiwa University exists only as paper-based syllabi, but not electrical or digital syllabi. And to develop a novel method of visualizing competency-based curricula by MDS, we manually constructed electrical or digital syllabi data using the Tokiwa competencies. Using this digital syllabi data, we developed a novel competency-based education, CBE, visualization in higher education, now IR. This shows that digital transformation follows competency-based education, especially in higher education, and CBE is based on informatics. Therefore, we conclude that informatics is a key to linking digital transformation and education. So, the answer of our research question is informatics. Informatics can develop original analysis or method for education, such as those shown in practical examples. Informatics has a good relationship with evidence-based education. This is conclusion. Thank you for your attention. Do you have any questions?
Thank you very
Thank you
much.
so much, Koniho, for your presentation. I see one hand up, Renyuan.
Thank you. It's me again. I'm sorry about that. So, Takamatsu sensei. So
Hi.
thank you very much for a nice presentation. So I have only one question. Do you think to develop such kind of methodology and systems for education informatics and DX systems, we need to think about the variation of the student levels and background and abilities. It's quite important basis, I think. For two different universities, to different countries, to different cultures, we should develop a different DX systems and methodology. Do you think so?
Yes, but in our university's case,
Yes.
the whole student is Japanese, and so there are very limited student preparation, I think. But in the future, I will try.
I hope
Thank
you
you
can
very
develop a
much.
system for my universities. Thanks a lot.
Yes, thank you very much. Good suggestion.
Thank you for your question. I would have just a remark for your presentation.
Thank you very much.
Maybe it would help to put like the labels on the X and Y axis because I wasn't sure how to read the figure. You're
Sorry.
showing like a nice figure with all the courses and the competencies between the courses. But I was a bit unsure how to interpret that figure. So it's just a very small remark.
Yes, sorry. So it is short time. So next, I will get good presentation. Thank you very much.
Okay.
Your remark.
Thank you so much.
Thank you. Thank you so much. So we have our next presenter, Billy Robeza. would be presenting your paper on integrated remote primary care infrastructure, a framework for adoption and scaling of remote patient management tools and systems, right? Billy, are you here? Are you able to hear me?
Yes, I can hear you. Can I share my screen?
Yes, definitely. You can start sharing the screen.
Is it visible now, or are we still struggling to get things going? Can you see it?
Not yet. No, I cannot.
I can't see anything.
Okay, let me just see what's happening on my side here.
Yes,
Oh,
now
perfectly.
I can. Yeah.
Okay, so you're able to see me now.
Yes.
Okay, so I'm associated with the University of Stellenbosch, as has already been mentioned. My name is Billy Ruyobeza, and I'm involved in research on health systems engineering, and we really interested, as you can see there, in adoption and scaling of remote patient management tools and systems. So basically, in the current dispensation of primary healthcare, potential patients have to subjectively evaluate their health status and decide whether it is time to visit a healthcare facility or seek some other kind of help. Of course, that could be perhaps too late, or they could be involved unnecessary visits to a healthcare facility, which is very wasteful in developing countries. Well, so this problem lead to obviously limited access and quality of primary healthcare services, increased care costs in terms of waiting times, late diagnosis, even misdiagnosis at times, is low morale and demotivated primary care workforce, as well as disempowered and dependent patient population. So this offers really a great opportunity, especially at this time, with the explosive uptake of smartphones in low-income countries, rapid advancement in body sensor technologies, the growing recognition of the enormous potential of artificial intelligence, as well as the improvement of ICT in general, even in low-income countries. However, if remote patient management tools and systems are going to make any impact, they have to be widely adopted and scaled in order to impact the community. Unfortunately, this is not the case. Even in developed countries, there's constant indication that adoption and scaling are problems. And we've gone out to initially find out what are the main causes that people mention. While there's consistent lack of empirical evidence to prove that these systems actually deliver the benefits that they promise. And secondly, there's limited contextual specific infrastructure and socioeconomic factors that negatively impact adoption during the process of designing it and rolling it out to the adopting population. And so we gone out and looked a little bit deeper to see what are the other issues that perhaps are less prominent in literature. And the first is really you find huge discrepancies in understanding what adoption actually means. To some, the mere download of an app would mean adopting that app, and yet it may be followed by abandonment thereafter. There is also an erratic approach to adoption that we found where it is an afterthought. So people go out, design these systems, roll them out in the field, and then find out they aren't being adopted and they want to find out why. And then, of course, the one that is mostly cited by experts is limited reliance on theoretical tools. And where it is used, where theories are used, we found that there is less attention to spatial and temporal dimensions of the theoretical tools used. So our question was, how, in this context, how do we develop a framework to guide the initiation, the planning, the design, and the deployment of localized in-community remote patient management tools and systems that are adoptable and scalable? Well, many of you would be familiar with the father of the sciences of artificial, Simon Herbert, who proposed that in order to predict how a framework such as the one we proposing would behave or would fare, we needed to build it and use it, assess it, and modify it in successive stages to improve it until we get to an optimal level. And that's really fitted with the design science research, mainly because the problem we are addressing, its prescriptive aspects are less mature than the analytical part or predictive aspects. And this is evidenced by the huge amount of literature available on the topic. And also this gives us an opportunity to address a class of design problems. In other words, how do you develop a technology where adoption doesn't mean just the acquisition of a piece of equipment or software? And finally, some design elements or some important elements become visible only through design. And so I will not bore everybody, might be familiar with this design science research framework of Hevner. And suffice to say, I wanted to highlight that in my task environment, there have been the healthcare establishment as well as design companies. And in the knowledge base, I have the foundations, the existing theories, models, instruments, and concepts. And then I have the methodologies to draw on. In terms of how my actual research looks, this is what it looks like with the different components, using reviews mainly to tap into the knowledge base and doing practical research in the task environment to actually draw the information that I need. The critical review here is what we're going to be talking about in a moment. And where are we now? Well, if you look towards the bottom left, you will see we have gotten to this level where we've completed our critical review and are proposing a design theory or the initial framework that we're going to be working on to improve. So how did we do it? Well, basically we started by modeling the adoption and scaling processes specifically for RPM TSS. And we found that there were 3 distinct phases that were critical, and each one had its own goals. For example, in the preconception phase, we want to set the groundwork, to get the groundwork done, the economic feasibility, the technical feasibility. We want to find the value proposition and advertise it, sell it to the adopting population, and fine-tune the requirements. And then on the uptake and acquisition phase, we want to focus on the point of contact between the new remote patient management tool and the actual adopters and see what is needed at that point. And that is what we design and work on at this stage. And finally, we have to adapt and embed the use of the tool within the healthcare seeking routines of its potential adopters. And so to move on from there, we created a topology that's very similar to what to the picture I just showed in the previous slide. And we set out what are the actual purpose, what is the actual purpose of each stage and stage gate within a phase that we've mentioned. And you will see here each phase starts with an assessment phase, stage gate, sorry, and then there is, we do something, and then at the end, we actually evaluate what we've done to see if we've achieved the purpose for what we want to do. And so we populated that with multiple theories that could align with that particular purpose. And later on, we did an evaluation and we're left with these particular theories that we were going to work on. And I will be able to share the initial model that emerged. And you will see, for example, we've changed the models around, and I will not be able to discuss this within this particular presentation. It's very short. But you will see, for example, when I use the FIT framework, the fit between technology and tasks. I do an assessment of the skills, not just within a job context, but of users, and also the tasks that they have to complete in order to achieve the desired purpose at that stage. And there is the program. And of course, the second phase, you will see in the actual point of contact. We mentioned that there is a need to hear of 3 components that are needed: the physical and psychological capability, the motivation, as well as the triggers and opportunity to uptake that particular intervention. And then just briefly to mention, towards the end, we get the lessons learned and build a case that we feed back at the beginning to improve the design of remote patient management tools and system. And then at the top there, you'll see we will have been tracking how the adoption has been going over time. So in conclusion, what are the takeaways? Well, really, it's that wisdom embodied in Lewis Carroll's well-known adage that if you do not know where you are going, any road will get you there. So adoption and scaling aren't going to happen in primary healthcare if there is no deliberate effort to actually target those goals and achieve them. So designers need to actually conceptualize what successful adoption means to them, and then put in place measures to achieve that. And such a holistic approach as we have shared today permits the designers to preview the adoption and scaling road ahead, along with its contours and corners that they need to turn in order to successfully arrive at their destination. Thank you very much, and I would be happy to answer any question. Thank you.
Thank you so much, Billy, for your presentation. Are there any questions? So I have a question for you, Billy. So in this design science research,
Yes.
How do you do the evaluation? Are you looking at some metrics? How do you know if you designed like a good system?
Okay, wonderful. So the main way of testing is actually in the task environment. If I go back to, I don't know if I'm still sharing, but I go back to the task environment. And within the technology design companies, there are experts that have been designing these systems for years, and they are familiar with the problem of low adoption and scaling. And we actually take the model and question them, research using, we want to use a Delphi model to actually set up questions to test the model, and we will improve different aspects as we go along. Yeah.
Okay. Thank you so much for this.
Sure.
Thank you. Thank you so much. So
thank you.
So we have our next presenter, Haifa Al-Sarar. Are you here?
Yes, I'm here.
So you would be presenting on Arabic dialogue systems survey, right?
Yes, it is. Can you give me the share?
Yes, sure. You can start sharing the screen. Not yet. The screen is not visible yet.
Okay. Is the screen
Yes, yes, yes. It is visible and you can start.
okay? Assalamu alaikum. Good evening, everyone. I am Haifa Sarrar, the presenter of this work, which is done at King Saud University in Riyadh, Saudi Arabia. Are you all hearing my voice?
Yes, yes, we
Yes,
are.
of course.
Okay.
Yes, yes.
Okay, this
Yes.
work, or actually this research, is talking about one of the most active topics in the field of computer science, which is NLP, Natural Language Processing. And the title of our paper is Arabic Dialogue Systems, a Survey. I will start this presentation with the motivation of our work, which is beside the fact that NLP is considered as an active topic in our technical community. Besides that, there is a lack of research that focus on Arabic language in the literature of dialogue systems, which we can also call conversational agents or chatbots. At the same time, Arabic language is one of the most widely spoken languages in the world, and it is the basic language in the Arab world. Because it is the language of the Muslims' holy book, which called Quran.
Haifa, sorry for the interruption. Like, the slide is not moving. Like, you are still on the first slide.
Okay, now.
Okay, so you are starting off now. All right. Please take care of the time. Yeah, you just have 10 minutes. So please take care of the time.
Okay, is the slides visible for you?
The slide is visible, but the slide you have not moved to the next slide. So I thought, let me ask you.
Okay, I will share the screen.
Okay, I think it works now, right?
Yes, it works. Thank you. Okay, sorry for the interruption. As I said, Arabic language is the language of the Muslims' holy book, which called Quran, and one of the Quran verses is بلسان عربي مبين, which means Quran has been written and spoken with this language, Arabic language, which reflects the importance of this language. Therefore, there is a need for high-level review studies to support the researchers in the field, Arabic dialogue systems, since the current survey studies only focusing on the English language. Therefore, our study aims to guide the researchers to focus on gaps in the area of Arabic dialogue systems. After that, I will move to talk about the research method that has been followed in this study. The research method followed in this study is a systematic mapping study, which means a general analysis of a specific topic in a specific area, which in our case, to gain an overview of Arabic dialogue systems. And it involves 3 stages: planning, conducting, and reporting. I will start with the first stage, where will we define the research questions, search strategy, and mapping protocol. Second is conducting, where relevant studies are picked and the obtained data is analyzed and synthesized. And finally, the last stage is reporting the results obtained from the mapping study. In the first stage, we will start with defining the study objectives. In this study, we have 2 main objectives. First, to review the published studies related to the following topics of the Arabic dialogue systems. First, the type of Arabic language. We have 2 types of the Arabic language: MSA, which stands for Modern Standard Arabic, and it is the formal language, and the dialect Arabic, which is the informal language that is used by Arab people in their daily life. Second is the type of the interaction between these systems and the humans. Is it written, spoken, or both of them, written and spoken? The second objective in this study is to identify the current state of Arabic dialogue systems literature, in addition to the main challenges in this field. After defining the research objectives, we will define the research questions, which are 4 questions in our study. First question, what are the thematic classifications in Arabic dialogue system? Second, what are the limitations and the challenges third question is, what are the areas of applications in Arabic dialogue system? And the last question in this research is, what are the methods and techniques used to design or to solve or to develop such systems? Now we will move to the conducting stage, where we reviewed published studies in the well-known technical databases such as IEEE, ACM, Springer, and Scopus. We also reviewed journals specializing in dialogue systems, but not indexed in the above database. We also used keyword-based search queries with different spelling variations for the paper title, abstract, and indexed terms. And finally, we filtered the results based on type of publication, publication year, and computer science subject area. So we start after that extracting and analyzing these data from the previous related studies, where more than 200 published studies with 224 review papers in the topic area were reviewed. And the data was extracted to answer the research questions. The data was extracted into a matrix form with the following items, which starting with paper citation information, subject classifications, research methods, technologies and frameworks, subject area, limitations, and challenges. After extracting and analyzing these data from the previous related studies, we can draw the results. The first result is answering the first research question, which is, what are the thematic classifications in Arabic dialogue systems in terms of type of Arabic language? As I mentioned, we have two types of Arabic language, MSA and dialect Arabic. As we can observe from the chart, the existed Arabic dialogue systems used MSA, the modern standard Arabic, more than the dialect Arabic, with 57%. The next result is answering the same question, but in terms of the type of interaction of these systems with the humans. As we can observe from the title, from the chart, the spoken system are the most existed systems in our field, Arabic dialogue systems, followed by written systems and then spoken written systems. The next result is answering the next or the second research question, which is, what are the limitations and the challenges in our field? After extracting and analyzing the data, we conclude with these limitations. First, the lack of tools and resources that are necessary for the development of such systems. Second, requiring a lot of time and effort when it comes to collecting data in Arabic language, because Arabic is a complex language to use in dialogue systems. And finally, there is no enough annotated Arabic spoken or written chat dialogues in Arabic dialect. These are the limitations and the challenges in our field, Arabic dialogue systems. The next result is answering the third research question, what are the areas of applications in our field? We will start with the written systems that are using MSA language. We have 4 different systems in 4 different areas, which are hotel reservation, home automation, education, and social media. In terms of the written systems that is using dialect Arabic, we have 2 different systems, Buta and Nabiha, which are in 2 different areas, entertainment and education. In terms of the spoken systems that is using MSA language, we have 4 different systems in 4 different areas, robotics, student community, multi-domains, and the human machine area. In terms of the spoken systems that is using the dialect Arabic, we have only 1 system, which is Hala in the robotics area. In terms of the spoken written systems, but that are using the MSA language, we have 2 different systems
Dear
in health.
presenter, we just have 2 minutes left.
Okay. In health and education areas. And finally, for spoken and written dialect systems, we have only 1 system in the call center area. The last result is answering the 4th research question, what are the methods and techniques used to design such systems? We have 2 main methods, neural networks method and rule-based technique. These are the main methods in our field, Arabic dialogue systems. Now we can move to the conclusion part. where this study provided a review and analysis on the published literature in the area of Arabic dialogue system. We collected the articles and extracted data to answer the 4 research questions, and answering these questions helped us in identifying the gaps in the Arabic dialogue systems. Therefore, the Arabic dialogue system has not received much attention using deep learning techniques, where most studies used the rule-based approaches. For future work, we would like to investigate deeper and build an Arabic dialogue system taxonomy with different views and different perspectives. Because our study is only a high-level review, we will extend the topics investigated to other dialects. We also will extend the time period, the database selected, and the type of publication. So this will enable us to have a much clearer picture of the Arabic dialogue system literature to support the community in identifying gaps and directing future research. This is the end of our presentation. Thank you all for listening. If you have any question, don't hesitate to ask.
Thank you so much, Haifa, for your presentation. Are there any questions? I have a question for you, Haifa. If you were to choose an application of the natural language processing that is so well, there are so much research for English, and you would want to apply it to Arabic, what would it be?
Apply it on what?
That's my question. Where would you apply it? Would you apply it in just a dialogue system, or in language classification, or
I prefer
would you start with you know that there are vector embandings in English? Would you construct those, the equivalent for Arabic, like word2vec and similar with that?
I would like to apply on chatbots, which is a part of NLP applications.
Mm-hmm. Okay. Okay, thank you for this.
Thank you.
Okay, thank you.
You're welcome.
We have our next presenter, Salah Caesar. We would be presenting on literature review of the model applicable to e-government in Peru's agricultural export sector. Thank you.
Okay.
So you can
Hello,
start.
everybody.
Hello. So
Yes.
you can start
Can
sharing
you
your screen.
hear me?
Yes, I
Okay,
can.
let's go. Let me see. Can you?
You can share your screen.
Yes, of course. Here is it.
Yes.
Yes, perfect. Good afternoon, everybody. Now we're going to talk about research. This research is part of a biggest one research that is my thesis from PhD. So here in Peru, we have a lot of problems. One of them is competitiveness. No? Our companies needs more competitiveness to grow up and fight with others, with other countries, commercial or trade. So I work for Agriculture Ministry. So we research about how to provide, how to companies must have more technology, more quickly, more faster. No, so here my name is Cesar Salas. Hugo Vega is here too, and Ciro Rodriguez of course. Today we're going to talk about 4 topics. What does the research consist of? No? Why this topic? Which problems we solve? And which are the contribution of our research? And finally, some contacts, because it's a small information, a bit information. If you want more information, can you contact us? So, my thesis is going about 4 papers. This is one of them. The red one is a literature review of TAN model applicable to e-government in Peru's agriculture export sector. So before we write a paper about critical variables for digital transformation, and then we need to write about contribution to the technology adoption model. We propose some factors to getting better this model, this TAN model. TAN model is technology acceptance models. No? And now it's under construction yet. We do a validation. This TAN model we call TAN 4 is an evolution from TAN 1, 2, and 3. And we apply this model to our sports sector, and we do a case of study. In which consists this paper. So we do a state-of-art literature review, from 10 years at least. 20 years. We review all of models, and we find 10 models and at least 36 factors related to these models and how they evolution and intended to solve the problem from how the person must adopt or accept technology in many sectors. No? We use for this paper systematic literature review. Consists in 3 phases. One of them is one of them is planning, conducting, and reporting. Is equivalence like the other speeches. I use QLI like a reference. So I use 3 phases. And this is the results. So in first phase, we find almost 40,000 of papers, of studies. So we use exclusion criteria, English, for example, periods of years. For example, the paper must talk about evolution of model, not applied model. This is a reference. So our scope was reduced, almost 500. And at the end, we use 38 papers for state of art of this research. And only 23 journals are related to this model. No? Why this topic? Which problem we need to resolve here in Peru? We work almost 20 years for Peruvian agro-export sector. My country is 33 million of people. At least 1 million of Peruvian depend of this sector, this a more growing sector. 15.8 is continue growing in the last year. And like a government, we need more competitiveness. Our companies related to this sector must be more competitive to fight out. No? Why this topic again? No? Because we use fruits, for example, and food safety standard or regulation are so hard, no? Are so increase the level. So we think that if we work, if our products that get out that export to the other countries, we contribute to internal consumer, no? Demand more quality. If the foreigner demand quality, the internal people do the same. So this is one of the topics. In this level, foreigner and Peruvian people win to win. No? And one of the other reasons is that Peru is one of the 10 most biodiversity country in the world. Other topics, which are the contribution of our research? No? We propose a resume 10 models. I said 10 models resume. And we study all the models, and we discovered that time needs to be extended. For this reason, one of my paper intends to contribute to extend the TAM model, no? TAM 4, I said. And we believe that future works develop need to propose new models, new methodologies, because there is not efficient right now. No, the future works research must validate, not propose a model and not validate. We must validate. A case of study is one of the research method. Finally, can you contact us in social network, ResearchGate or LinkedIn, and we can share more information, appendix, annex about the research. No, so I open to any question, please.
Thank you so much, Cesar, for your presentation. Are there any questions? I think there are no questions so far. Are there any other presentations for this session?
So we are almost done. We are done.
Okay.
So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. I also thank our session chair, Anila Meron, for chairing this session. Thank you so much, ma'am. A token of appreciation to the chair on behalf of Team ICICT 2022 and Global Knowledge Research Foundation. I would request all to on your camera for a quick snapshot in the virtual conference. Can you please on your cameras?
I'm sorry, Ms. Chair.
Yes, yes, yes.
Can I have 1 or 2 minutes? So could you please show your agenda slide, my face page? So I want to snapshot the screen and I need to refund to my company, to my university.
Sure.
I'm sorry. Thanks a lot.
Just, you are,
No, my face. Okay,
fine.
yes, perfect. Perfect. Yeah, exactly. Thanks. I think let's see. Oh, I'm sorry. Wait a moment. Okay. Oh, I'm sorry. Here. And okay, it works. Thanks a lot.
Thank you so much. Thank you. So I'm just capturing a picture.
Yeah. Thanks.
Thank you so much, everyone. Thank you. It's done. Thank you, everyone. Take care. Stay safe. Bye.
Thank you, everyone.
Bye-bye.
Bye.
Thank you.
Have a nice day.
Bye bye.